How's everybody doing? I'm not there today. I'm not feeling too hot, but you guys are still going to be able to get your work done. If you guys just kind of follow along, I'm going to read through the chapter, and then when you're finished, you can go on to Schoology and answer the questions. So I'm going to click on the online book, since I'm assuming most of you don't bring your book to class. Let me make this smaller. Okay, so section 5 is called Water Underground. The key concepts you guys are going to learn about are how does water move through underground layers of soil and rock, and how do people obtain water from an aquifer. Here are the key terms, as you can see: permeable, impermeable, saturated zone, water table, unsaturated zone, aquifer, and artesian well. I'm not going to get to all those today, but we should be able to get to the first couple. So before we start, it says on your handout to write questions that you may have. And as you read, you can answer them. And here's an example. The first one is, what is an artesian well? On your own worksheet, please go ahead and fill in some questions you might have right now. So this might be the paper that you have in front of you, and you can see that you can write your questions and answers right here. And as I read along, I'll click back and forth, and we'll answer these questions together. So let me go back to the book. Skip over this, we'll do this later this week. And it brings the first scenario. It says, when you were a little child, did you ever dig a hole in the ground hoping to find a buried treasure? You probably never found a trunk full of gold, but there was a certain kind of treasure hidden underground. If you had dug past the tangled grass roots and small stones, the bottom of your hole would have filled with water. You would have struck groundwater. In the days before public water systems, water underground was truly a hidden treasure. Today, many people still rely on the water underground to meet their needs. Pretty much you guys have learned about groundwater before, but this is saying that we're going to take it a step further and understand how water comes from the sky, hits the ground, and then soaks into the ground below, and how it collects and forms wells. Alright, so I'm going to move on. Just to let you guys know, my wife said it's a good thing that we're not recording my actual face, since my hair is standing straight up on my head. So it's good that it's just my voice. So we're going to stick with just my voice and move on to the next page. How water moves underground. Okay, here it says, where does this underground water come from? Like the water in rivers, lakes, and glaciers, it comes from precipitation. Recall that precipitation can evaporate, run off the surface, or soak into the ground. If water soaks to the ground, it can trickle downward, following the pull of gravity. If you pour water into a glass full of pebbles, the water trickles down around the pebbles until it reaches the bottom of the glass. Then the water begins to fill up the spaces between the pebbles. In the same way, water underground trickles down between particles of soil and through cracks and spaces and layers of rock. Just look right here how this sentence is bolded. This is definitely a key sentence. This is going to talk about 2 of your new vocab words. So pay attention to this next section. Effects on different materials. Different types of rock and soil have different sizes, spaces, or pores between their particles as shown in this figure. And when I click this picture here, you can see that this is a great picture of how water trickles down below the surface. And this should be in your handout too on page 3. You can see here's grass. Water would hit the grass and travel downwards as gravity pulls it. And right here it says permeable layers. These are layers where water can actually travel downward and in between. You can see small specks of blue right here and right here. And this way, here's the unsaturated zone, which does not have much water in it. As we get further down, you see pebbles and rocks, and you see this small area here called the water table. Think of the water table, we're going to hit it in a second, is like an area that is the beginning of a collection of water. And right below that is the saturation zone, where it's actually wet. So if you were digging down in this grass, you'd be like, where's the water? Where's the water? And as you get down further, you would hit this thing called the water table, eventually coming to the saturated zone. I guess we're going to go back to this picture in a second, but in the meantime, I'm going to go back to the reading. So, we want to know what the definition of the word permeate is. It says the size of the pores determines how easily water moves through rock and soil. If the pores are connected, this too affects the water movement. Because they have large and connected pores, materials such as sand and gravel allow water to pass through or permeate. They are thus known as permeable materials. Impermeable is a characteristic of materials such as sand and gravel through water can easily pass. Again, this is where water can easily pass through. Think of things where water can pass through, such as sand and gravel. The opposite of that is impermeable, and this would be like clay and granite. And clay and granite are impermeable because water cannot pass through them easily. And we come back to our picture here, where you can see that these are the permeable layers like sand, and then below that is this impermeable layer where it's very thick, maybe clay or granite or rock, where water just can't pass through it. There's no water table below that. The water table is above it. This would be a good time to go back to your worksheet. If I can find it, right here. Okay, so now we're back to your worksheet, and I think we've answered number 1, how water moves underground. It says precipitation that soaks into the ground trickles downward due to, and what goes in that blank? You got to think, well, what makes water go down? What makes precipitation happen? So if you know the answer to that one, go ahead and put it in. If you're not quite sure, go back to the reading and check it out. This section below it with the terms and the definition, this is going to be one of your ticket outs and your ticket ins in the next couple days. It's 6 vocab words and their definitions, and you're going to see these in the next couple days multiple times that you have to know for Thursday's lab. So if you fill them in here, that'll be very easy for your ticket out in Schoology to complete, because it'll be the very similar questions. Alright, let's go back to the reading again. Let's find out where we left off. Okay, so we left off here at groundwater formations. It says differences in the materials that form layers underground determine where groundwater forms. Water can move through certain layers but not others. And then it asks you to interpret this diagram. What is the saturated zone and where is it located? So we look back at this big picture that you have in front of you, and you might see the saturated zone is here, and you can see water in the saturated zone. And if you know what the word saturated means, you know that it means wet. So this is the wet zone. And if you look at the unsaturated zone, it's the non-wet zone. So there's the difference in this diagram. And you should be able to see it and label it on your sheet as well.
What you brought over here?
Oh, you guys might have heard my wife just now giving me the water in my water bottle. I know you can't see my face, but I'm about to take a drink. Delicious. H2O. All right, let's keep going. The area of, where did I leave off? I'm sorry. Oh, the top of the saturated zone is the water table. If you know the depth of the water table in your area, you can tell how deep you must dig to reach the groundwater. So let's click on these vocab words so you have a good definition. Again, the saturated zone is the area of permeable rock or soil in which the cracks or pores are totally filled with water. Again, permeable means lets water through. And then we have the water table, and this is the top of the saturated zone, or depth to the groundwater under the surface. Think of this as the water table is how far do you have to dig until you reach water. So imagine going to the beach, and you're sitting on the sand right next to the water, and you start digging a hole, and then your dad falls in it, then he gets out, and then you say, oh my gosh, there's water to the end of our hole. That is because you've hit the water table. And it's different levels in different areas, but if you would dig outside your backyard right now, eventually you would most likely hit water. Alright, so we're almost done this section. I'm not going to go any further today in the reading. Again, you have a science book. You can get it out, read it yourself. I'm reading straight from the science book. I'm just on the online version. But we'll do this reading checkpoint, and then right when you guys finish this, be sure to answer all the questions on your packet, and then go to Schoology and take the ticket out. And I know you guys are going to be awesome for the substitute teacher and be respectful and all those things. And you guys are an awesome class, so just keep being awesome. So, reading checkpoint, and then I'll finish up and stop talking so much. A reading checkpoint. Which of the following is not an example of a permeable material? Is it clay, soil, sandstone, or foam, rubber? Again, not an example of permeable material. So the opposite of permeable would be impermeable. I'll give you about 5 seconds here to make a decision. Okay, so which one is not an example of permeable? I'm going to click clay and see what happens. That check mark is correct, meaning water cannot go through clay, and it will flow through soil, sandstone, and foam rubber. So this is a good example of impermeable or not permeable material. All right, that's it, guys. Thank you guys for watching, and be sure to just finish your packet and the Schoology. Thanks. Have a great day.